Welcome back, mathematicians. Today we're learning about two really useful ideas in trigonometry, angles of elevation and angles of depression. These show up in tons of real-world problems. Things like trees, ladders, buildings, lighthouses, and more. What I love about these problems in the real-world application is knowing that I could figure out how tall a very tall building is just by measuring a few things on the ground. The funny thing is, the most important first step in these problems isn't even the math, it's the drawing. So if you love to draw but you don't like math, you're in the right place. Once you have a good picture and a good triangle from the picture, the rest is super easy. Just a reminder, you will be using sine, cosine, and tangent ratios inside of right triangles that look like this. If this skill is a bit rusty, or this looks a little overwhelming, check out the link below to watch my trig ratios video first. It's the video that I like to present right before this one. You can also practice on my free worksheet and then come back here to learn how to apply these trig ratios. For now, let's get started with some drawings. Let's start with drawing a line of sight. Whether you're working with elevation or depression, we're always going to start the same way, drawing the line of sight. The line of sight is always parallel to the ground, and sometimes is the ground. So if we imagine that we are a stick figure standing on the ground, and here's our ground. The line of sight is pretty easy. It's going to come straight out from our stick figure where they would be looking straight forward. If it was an airplane, so let's imagine that we have a plane up in the air. The line of sight is coming straight out from the front of the airplane as well. Notice that in either direction, whether it's coming from a person standing on the ground or an object that's on the ground or something that's up in the air, the line of sight is parallel to the ground. This is really important. Another way of viewing the line of sight might actually be if it is the ground itself. So if we say that we have something like a building, and we are propping something up against it, like a ladder. Draw our ladder here. When we're talking about line of sight from a ramp or a ladder, this is going to be the same as the ground. This is our starting point. The line of sight is the most important part in drawing the triangle and the angles that you will use. So now let's work specifically with the angle of elevation first. Let's start with a classic problem of a person standing a little ways away from a tree. Normally we can't tell the height of a tree. The line of sight, again, is straight out from the person's viewpoint, which happens to also be parallel to the ground. Now, if you're not given the height of the person, then we're simply going to draw a line that goes from the bottom to the top. And this becomes our triangle. When we are given an angle of elevation, this is where we put the angle of elevation here. So how is this different than the angle of depression? Let's imagine rather than standing on the ground, our person is now standing on a cliff. Remember that no matter what the person is looking at, the line of sight is always parallel to the ground. If you haven't been given the height of the person, then you can draw the angle from the bottom. Now let's imagine that way down below, this person is looking at a boat. On the water. The angle that we're going to draw is from the person straight down to the boat. The line of sight, remember, is parallel to the ground. So our angle of depression is up here. This is really important. This is not the angle of depression. The angle of depression comes from the line of sight. That means that in this example, our triangle is actually upside down. So when we go to draw our triangle that is represented in the first situation, we can draw a right triangle that looks like this. And the angle that we're given of elevation is here. When we go to draw a triangle for the angle of depression, we can draw a triangle that looks like this. And our angle of depression is from here. So this is how we know which angle and which triangle we're going to be using from the drawing. In this video, we are going to be focusing on angle of elevation problems. We're going to do 3 different angle of elevation problems. If you also want to do angle of depression problems, please stay tuned and follow my next video. All right, so this is our classic problem of the person that is standing away from a tree. So we're going to draw our person here. We will draw our line of sight, which, since we were not given the height of the person, is also the ground. We are told that this person is standing 30 feet from a tree. So we're going to label the distance from the person to the tree 30 feet. Now your drawings don't have to be perfect. They're going to be just fine in illustrating what you need to draw. This says the angle of elevation. So I know that we're going up from here to the top of the tree, and it says it is 24 degrees. Remember that this is our angle of elevation. Think about it as a ramp. And that means that we are trying to figure out what the height of the tree is right here. Now that we have a really good drawing of this, and I'm going to move it over just a little bit, we're going to follow that up with a more simple triangle. So we're going to draw a right triangle that looks just like this, but over here. And we're going to label it exactly the way that we've already labeled our drawing. We know that the angle of elevation is right here at 24 degrees. We know that this distance is 30 feet, and we know this is what we are looking for. So we're going to label that x. Now we can simply use our trig functions from SOHCAHTOA to help us solve. To use SOHCAHTOA, it's very helpful to first identify what you've been given. Our angle is here, so we have to orient to our angle and figure out what we have. According to this angle, we have a number that is adjacent to the angle and a number that is opposite to the angle. Remember again that if this is a little bit confusing to you, follow my previous video on trig functions and ratios. Since we have opposite and adjacent, that's how I know I'm going to use tangent. So I'm going to set this up with the tangent of 24 degrees equals opposite over adjacent, x over 30. Now I need to simply solve for x. To do that, I am going to multiply both sides by 30, like this. That's going to give me x equals 30 times tangent of 24. This is what we're going to put into our calculator. When I do that, I get 13.3568 on and on because it's an irrational number, and I'm going to round that to 13.4 feet. Let's do another one. In this problem, we have a ramp. Remember that for ramps, the line of sight is going to also be the ground. This says that the ramp is 14 feet. So we can label 14 feet. It also says that it makes a 23-degree angle with the ground. What we're looking for is how high that ramp rises. Maybe that ramp was up to a deck, and here's the railing of the deck. So this is the height that we're looking for right here. Remember that our picture is just to give us an idea of how to represent this with a good triangle. And so our next step is to actually draw the triangle. And we're going to try to draw it in exactly the same way that the picture represented the triangle. So we have our 23 degrees here. Our hypotenuse is 14, and we are looking for x. Again, let's go ahead and orient ourselves to what we are given. This is our angle. So this is opposite our angle. And this is our hypotenuse. Remember from SOHCAHTOA, if we're given opposite and hypotenuse, that's how we know we're going to use sine. So this is the trig function I'm going to use. So I start by saying sine of 23 equals opposite over hypotenuse. So x over 14. And again, now I just need to solve for x. This gives me x is equal to 14 sine of 23. And when I put that in my calculator, I can round it off to 5.5 feet. Let's try one that's just a little bit more complicated. This problem is pretty complicated, which is why we can rely on a picture to make the triangle and all of the math much more clear. This says a 15-foot ladder is on top of a fire truck, and that the base of the ladder is 8 feet off the ground, making a 65-degree angle of elevation from the top of the truck. The top of the ladder is resting on the building, but they're asking us how far up the building does the ladder reach. Let's pull out our really good drawing skills to make this clear. First of all, we need a fire truck. It doesn't have to be the best of fire trucks, but they look something like this. We have a ladder that's being extended from the top of the truck. So I'm going to go ahead and draw our line from the top of the truck to resting up against a building. Let's go ahead and make a rectangle for our building. Now, if we want to be fun and funny, our building is also on fire. Ah! Either way, though, what it's telling us is that this ladder is 15 feet. It's also telling us that the base of this ladder is 8 feet off the ground. Let's draw our line of sight at this point so we don't get confused. We're being told that the base of the ladder itself is 8 feet off the ground. That's going to be this number here, which means that we have an extra 8 feet here outside of our triangle that we're going to use at the end. It says that the ladder makes a 65-degree angle of elevation. And this is where we're going to put that. And of course, at the top is resting up against this burning building. You can see the triangle that we need, but be very careful that at the end we don't forget that we're actually starting from 8 feet up the ground. We're going to draw our triangle to look exactly like our picture so that it is as easy as possible for our mind to understand how to label it. We start with our angle of elevation right here at 65, our label of 15 feet, and we are looking for how high the building is. But we have to remember that we have a little extra 8 feet to add on at the end. Again, we're going to orient to this angle. We have a hypotenuse, and we also have an opposite. That's the SO in our SOHCAHTOA. Opposite over hypotenuse tells us that we need to use sine. So we're going to use the sine of 65 equals x over 15. Now we're going to solve for x. We'll multiply 15 on this side and this side, which leaves us with x equals 15 sine of 65. So x equals 13.6 approximately. Don't forget, we have to add in that extra 8 to figure out how tall the building is. So this gives us a total length of where the ladder reaches of approximately 21.6 feet. Now don't forget that there's a free worksheet in the description to be able to practice these problems. Good luck, mathematicians!